All right, good morning, everybody. Today we're going to keep going with intro to baking. We're talking about leaveners. Well, not all of them, but most of them. So let's go ahead and get started. Okay, so yesterday we left off with this slide with different types of sweeteners and how they work. So today we're going to keep going. So to different types of leaveners, and by leaveners, it just means leavened, to rise pretty much. Dough or batter rises. So if you're making a bread dough or you're making cake batter, waffle batter, whatever, all those can rise. You have to be very specific with measurements. That's kind of make the difference between a savory chef and a pastry chef. Savory chefs, there's a lot of adjustments that could be made. It's not exactly precise most of the time because like if you have a recipe for, a 10-pound piece of meat and it comes in at 11 pounds, you need to adjust seasonings to it. You know what I mean? So there's a lot of variances there. And then some things taste different, so your water that you use for your stocks might have more sodium in it than the water that's, in a, if you get filtered water. So there's so many different chemical or leaven, differences there that, there's seasonings to adjust, that kind of thing. Whereas baking, it has to be exactly precise. I just made that up. Because it's chemicals and it's reactions and it has to be like on point. So very careful measurement. You have chemical leaveners, organic, and physical. Okay, we're going to go through these. Basically, a chemical is what it says. So it's a chemical, either being baking soda or baking powder. So like a man-made compound that will make your food rise. Organic would be your yeast because yeast is naturally in the air. It's a fungus that is all around you. But then they, have compact yeast too, where they just have a living yeast. Okay, physical is using steam or air to like whipping, like, and we're going to talk about this more, but steam would be putting butter into your croissants, which you're going to see a video on, and the steam of that forcing the product to rise up. Another one is just manually whipping it in there. So if you were to take egg whites, and you're going to see that, and whipping them until they form a matter. Okay, so the first one we're going to see, or this first picture, is baking powder. Okay, there's two big differences between baking powder and baking soda. So baking powder, main points, is a chemical leavener. It produces carbon dioxide gas. It makes batters rise. And it literally is baking soda and acid in an inactive ingredient. And heat and liquid causes leavening to occur. So baking powder is literally, they have a baking soda base and they add a dried powder to it that's acidic and probably something like creme of tartar, which is an acid, but powdered acid. Then they put a non-caking agent in it so it stays in a powder form. So the second you add liquid to this and heat, it rises. It starts doing the same effect that would happen as if you had baking soda with an acid. All right, but it's all in one combined package. But it's a little safer to use this one because you're going to get the measurements correct. All right. If you've ever seen a recipe for buttermilk biscuits, typically buttermilk biscuits have a baking powder or baking soda in them, and then buttermilk, which has acid in it. It's literally milk, like a cup of vitamin D milk, and 1 tablespoon of lemon juice or vinegar, and it's mixed together. And the acidity from that mixed with the baking soda will make something produce gas and rise. So I put a couple of pictures in here. So when you see these bubbles, and the reason you want this, if you don't have a leavener in your cakes and stuff, you're not going to get these bubbles. And these bubbles come from either a chemical leavener or a physical one. Okay, so this is a basic dense cake. It looks like a white cake with maybe cherries or something in it. But the bubbles and the gas that makes this thing rise are the baking powder. Okay, same thing with cookies. The bad thing is you really have to be careful because these same chemical reactions can happen like inside you, like in your stomach, if you don't watch this carefully. Like you don't want to overdo it with your baking powder or mismeasure this because it could make you sick. All right, so let's just keep on going. Next, we have baking soda. So baking soda, chemical leavener, sodium bicarbonate produces carbon dioxide gas when it's mixed with liquid and acid. Remember the first one, baking powder already has the acid in it. So you can just put liquid in there and it's going to produce the same thing. Batter rises, heat's not necessary, but bake it immediately. Like you don't want to mix this. That's why like pancake batters and those kind of things, you want to do them day of or that day, like day of. You don't want to keep them in the fridge for a couple days. One, it has a really bad effect. Like if you leave pancake batter in the fridge for a few days, it turns like gray. But once all the gas, once basically all the baking soda has been eaten up or used up, you're not going to have the chemical leavener anymore. It's just going to produce all the gas and it's done. So we have some more things. Oh, so this says on the bottom that one of the acids you could and I didn't even think about that. So the different acids you could put in here, there's lemon juice, vinegar. This suggests that you could use yogurt or buttermilk. We'll talk about buttermilk. I forgot about yogurt. That has an acid in it too. Probably sour cream. All these things provide acid. Then it says other less reliable reactants are honey, molasses, cocoa, and chocolate. Because heat is not necessary for a leavening process to occur, bake them right away to prevent the gases from escaping and leaving the item too soon. So pretty much what I just said. So you don't want these to sit around for a long time. Okay, I'm going to show you this. If you've probably seen these videos before, but this is taking baking soda and adding vinegar. Sorry, make it bigger. You know what? I need to put this so you guys can actually see it well. My bad. Okay, so this is the baking soda and adding vinegar. Move him ahead. So he puts him. Add in the baking soda. Just watch what happens. And this is the same thing that would happen once you mix this into a cookie or your batter, okay? This is going to overflow all over the place because there's nothing holding it down. But like with yeast, imagine if this reaction happened in a thick, and it's coated with flour. So it's going to make that same effect where you see the bubbles coming up, but it's not going to escape so rapidly because it's completely surrounded by a thick mass of flour or gluten-free flour, whatever you're using. But you see how many bubbles this produces? So that's where the same reaction would happen in your cookies or your cake batter. But watch, because after a little bit, once this reaction occurs, it's going to dissipate. Like it's just going to go completely away. See how it's starting to slow down? That's the same thing that happens in your batters. So the good thing with having a batter is it traps a lot of that gas in there, but you have to cook them pretty quick. Cookies, you're a little safer because there's not a lot of liquid in there, but like pancakes, cakes, those kind of things, that goes away. You have to cook those pretty rapid. Okay. And then it'll lock that gas in place. You're basically just keeping in that gaseous, state. So yeah, that's what happens. So you can kind of see exactly, how long it lasts, how long it'll go away. If this isn't a batter, the batter would last, about an hour or so, but it's not going to last all day, and you can't keep cooking it for several days. So, all right. So that's that one. This last slide, I think this is the last one we're going to do. Yeah. This last slide talks about physical leaveners. So physical leaveners introduce air into batter. The air expands during baking. Creaming method is one of them, where you blend fat and sugar, which I don't know, I think I had a video on that already, but that'll probably be the first thing you learn once we do cookies. And it's just basically you're incorporating those two things together, and you're bringing air into it. Okay, so you're going to make it actually rise with incorporation of air. That's for cake and cookies. Foaming method, eggs with or without sugar. So if you're making certain types of cakes, so your angel food cake, meringues, angel food cake, sponge cakes, and then another one you make is meringue or souffle. And I'm going to show you in here. This is a meringue. So it's a couple different things you can do. This same method is going to be used for making cakes or just making regular meringue. And the last one is steam. So cream puffs, pie crust. And I put a thing of croissants in here because croissants use two different types. They use yeast as a leavener, and then also they use butter, because the steam from the butter also helps create that big fluffy pockets of air. And this is a video on how to make croissants. So I want you guys to see that too, because it's very important to see how they use multiple different methods. So this first one, how to make meringue. It's pretty simple. If you've never had meringue before, if you've ever had key lime pie and they have or lemon meringue pie, they have the thin layer of custard pie, and then the meringue's the white fluffy stuff on top that they usually take a torch to, and it tastes almost like a marshmallow once it's torched. Okay, hold on, let's watch this. Oh, I think I still have it on super speed. Oh, no, I don't. Okay.
Meringue is stiffly beaten egg whites and sugar. There are a few styles of meringues. Here are two of our favorites. French meringue is an unheated meringue that should be cooked on top of pie, such as in lemon meringue pie or as the base of meringue cookies and shells. Get ready. Make sure your egg whites and equipment are clean. Even the smallest drop of yolk or oil will keep them from reaching their full volume. Start with room temperature egg whites.
Okay, so a key to that, what he just said, when you're whipping egg whites are just all protein, okay? Well, there's a lot of albumin and other stuff in there, but they're mainly protein. There's really no fat in it. So when you separate your eggs, which we'll learn how to do, I think we talked about this a long time ago during breakfast cookery. When you separate your eggs, you have to be really careful not to poke the yolk and get that into the batter, because it's going to keep it from rising. And then when you first start with your bowl, the best thing to do is take a little bit of lemon juice on a towel and wipe out the inside of your bowl, because if you use this same bowl for cookies and all the cakes and all the other stuff, especially cookies, fat will get smeared on there. If you don't properly get that fat off, it's not going to come off. So you want to make sure the fat's off.
Higher. Add a pinch of cream of tartar. It's acidic, and that adds stability and volume to the egg whites. Whip them until they're foamy and starting to get thicker. Then, slowly add confectioner's sugar. It melts easily and won't weigh down your meringue. And whip on high speed until it's thick and foamy like shaving cream. If it's glossy and is tripled in volume, you did it. No need to take it further or the texture will change. A Swiss meringue is a cooked meringue, and it's also more stable, meaning it won't collapse. This meringue is used in buttercreams, or can also be poached for the classic dessert floating island. Combine egg whites and granulated sugar over a double boiler. Keep whisking, or you'll have scrambled eggs instead. Whisk until the sugar melts and you hit 130 degrees Fahrenheit on a thermometer. Once it's hot, it goes into the mixer. You want it to be foamy and thick when you're done mixing. You'll also notice that as it thickens, the bowl will get cooler. Whip until you get stiff peaks that should stand up on the end of the whisk. And your desserts will receive a standing ovation.
All right. So that one, you guys will see, there's many different things you can do with the meringues. The second one I want to show you guys, and it's a really cool process where this guy makes these croissants. And you'll see that there's two different ways. There's the physical and organic way they leaven.
I'm Keith Cohen. I'm the owner of All Washers Bakery. We're in one of New York City's oldest and most iconic food establishments. And this is how we make our croissants. I want to take this opportunity to introduce Youssef. He is our croissant master. Here in our giant mixer, we're going to add flour, milk, salt, sugar, milk powder. He adds milk powder because it's dehydrated, so it acts more as a solid. When we first met Youssef, we tasted this croissant. So when you look at it and you taste it, you don't change his recipe. Yeast, water. Ice water is very important, especially during the summer. It brings the mix temperature down. So you don't want too hot of a dough, because what's going to happen is the dough is going to proof, but more importantly, your butter is going to start to break down. And finally, butter. We source our butter from France. Every country has their own terroir. Because butter is so integral to the taste of the croissant, we felt it necessary. Once the dough is mixed, we want to be able to pull it out and chunk it into 6-kilo increments. Much like a lot what we do here, there's a resting period. Pre-shape gives strength. This is one of the critical things, almost like bread, is you have to give strength to your dough. In order to pre-shape it, you want to make sure you're gentle with the dough. You want to fold it under itself without damaging it too much. That dough has to have that stretch and that shine. When we talk about letting the dough proof or rest, you'll also see about a doubling in the size of the volume. You're going to punch the dough down. After it's doubled in size, it's going to give it a time to deflate. You'll take a little bit out of the gas. It will tighten up on you a little bit, and it'll be ready for the freezing process. During the freezing process, because we're not doing blast freezing, the dough is still fermenting, which is also very important. One of the keys to croissants are there's not only butter in the dough, but there's butter that gets laminated into the dough. So you're putting dough with butter sandwiched, and then you are passing it through a sheeter, which stretches out the dough and makes it a little bit thinner. Again, what you're looking for is that layered effect. The way you're able to do that is through folding the dough again and then turning it. So it becomes exponential. Don't hold me to my math, but once you have 4 layers, your next set you will probably have somewhere around 16 layers. And the sign of a good croissant is you should be able to see the laminates. Once it's finalized sheeting, it's now ready for cutting. So we have to have a 10-foot table now so we can lay out the entire sheet. And again, it is about the timing. So we're able to cut it quickly. After it gets cut into strips, it now has to be cut on the angle so you can get that beautiful triangle. The shape of our croissants aren't crescent, they are oblong. Youssef has developed, I believe, is somewhat his own technique of taking the croissant and giving it a little bit of a stretch. And with each little stretch or each little pat that you see it does, it gives a little bit extra, so you get an extra roll, and at the same time it gives it a little bit more strength. So in addition to our regular croissant, we do a pain au chocolat. It's a little bit easier to roll, but again, there's a technique, the way we use the chocolate batons, and making sure that it's rolled tight enough so they don't melt when they're baked. Once again here, temperature is working against us. Once we're done rolling the particular sheet, whether it's a plain croissant or a pain au chocolat, we're going to put it right back in the freezer. The proofing stage is a highly critical stage for croissants. Things that get overproofed could have a tendency to collapse in the oven, and or one of the key indicators is the butter coming out of the product. The egg wash gives a nice shine to it. It's more aesthetics. We bake our croissants off at 350 degrees in a convection oven. What's happening now that the heat is starting to bake the croissant, again, you are getting some oven spring to it. You are developing that beautiful honeycomb interior. The butter is starting to melt throughout the product, not completely out of the product, but into the product itself. And again, through the Maillard reaction, you're getting a beautiful crisp crust to it. Best time to enjoy a croissant is when it's room temperature. You're allowing the butter to get reabsorbed into it and allow some of the gas to escape. It's very important to achieve all your full flavors after the product reaches room temperature. When you cut it open, you'll see this beautiful honeycomb interior, and that is really one of the keys to a great croissant. On a well-baked croissant, you should have a beautiful crackle to the crust, and you should have a soft and supple interior, and the butter, if it's high quality, should taste very, very neutral. To me, croissants are the epitome of French baking, and that is how croissants are made.
All right. Amazing way how they do that. It is a very time-consuming way of making a bread, but they turn out delicious. But you saw, so you have the yeast in there, and then also the steam, the butter, the whole chunks of butter comes, helps push out. And that's one way to make them. I've seen people make them different ways too. So that's what I want to just have you guys go through today. It's not a ton. We're going to kind of take baking slowly just because there's so many different aspects to it. And then we'll probably do a whole lesson just on measurements, just so you guys get that idea going of like how to do that properly. So that might be the first week we come back, is just doing measurements. So that's what we have for today. There'll be 4 questions for you guys, and I will see you later.